In this lesson, the student's going to use a gizmo and a worksheet to piece together Pangea. So the student will be able to cite evidence of continental drift based on the fit of the continents, fossil evidence, and climate indicators. The student will use vocabulary such as glacier, fossil, and ice age to explain the evidence for continental drift. Links to prior learning. Earlier, we learned about claims, evidence, and reasoning. We're going to find evidence to support continental drift. We learned about convection currents in the mantle. That's the driving force that pushes the continents. And we learned about the layers of the earth. Vocabulary. Glacier. A glacier is a large accumulation of ice, snow, rock, and sediment, and water that originates on land and moves down the slope under the influence of its own weight and gravity. Ice age is a glacial episode during a past geological period, and a landmass is a continent or a large body of land. Errors to avoid. Continental drift takes place slowly. The continents move about as fast as your fingernail grows. That means it takes a long time for them to move any large distance. The Earth has been here for a long time, 4.5 billion years. The error to avoid is to think in normal time frames. Time stretches out much longer than is normally comfortable to think about when we think about geologic events. For this lesson, you'll need to use the gizmo I provided in the link and the Google Doc, Building Pangea. Pause the video and get those ready. All right, I'm going to start by putting my name in Gizmo and the date. All right, and reading. Student exploration, building Pangea. Directions. Follow the instructions to go through the simulation. Respond to the questions and prompts in the orange boxes. Vocabulary. Continental drift, fossil, glacier, ice age, landmass. Pangea, supercontinent. Prior knowledge questions. We're going to do these before we go to the gizmo. So Antarctica is a frozen land. That's the continent that's at the South Pole. It's so cold and icy that no trees can grow there, yet scientists have discovered fossils, remains preserved in rock, of ancient trees in Antarctica. What do you think this means? I think this means it was warm there before. Okay. Another thing that you could think it means is that Antarctica was part of Pangea, or it was part of the continent. All right. The Himalayas in Central Asia are the tallest mountains in the world, but fossils of seashells can be found high in the mountains, far from any ocean. How do you think seashells got on the top of the tallest mountains in the world? I think that land was underwater at some point. Okay, Gizmo Warmup. The gizmo allows you to drag and rotate all the major landmasses on Earth. To drag a landmass, grab it in the middle. To rotate a landmass, grab it near the edge. Learn the names by opening the Tools menu and dragging the Help icon over the landmasses. Mark where you live. Open the Tools menu and drag an arrow to your location. Okay, so I'm opening Pangea, and we will do that. We will move the landmasses and move them around. Okay. All right, so I'm going to drag a landmass by holding it in the middle. I'm going to turn it by holding it at the ends. So I notice that the icon changes when I get away from the middle of a landmass, and it changes again. So two things to do there. Okay. So move this around. Okay. And this is Antarctica at the bottom of the world. And here's the tools. So I can use arrows, drag an arrow, and I'm going to drag an arrow to the tools, and here's where I live, right there. That's where I live. It also says that you can hover over and you can see the names of the continents. So there's Greenland, Eurasia, Arabia, India, Australia, Eurasia, Africa, Antarctica, South America, North America, Greenland. Okay. Test your geography skills. Drag and rotate the land masses randomly until you make a big mess, and try to move them back to their original positions. When you've made the best map you can, open the Tools menu, select Screenshots, and paste the image below. Label the image Map 1. Okay. So let's drag these until we've made a big mess. I'm just going to put them all into a big pile. Like that. Now I'm going to put them back where I think they go. So Eurasia, I think I turned it a little bit. Africa, Arabia, somewhere over here, Antarctica, South America, North America, India, Greenland, Australia, and Madagascar. All right, now I'm taking a screenshot to see on my computer. I'll take a screenshot a different way. All right, and now I put the screenshot in the. Let's see here. There you go. And I'm going to label this Map 1. All right. Now I'm going to go back and click Reset and see how I did. Not bad. How well did you do? Not bad. Okay. Activity A, solving the puzzle. Get the gizmo ready. If necessary, click Reset. Check that the evidence shown is none. So, evidence, none, reset. Okay, good. Introduction. In 1915, a German scientist named Alfred Wegener proposed the theory of continental drift. According to this theory, the landmasses were once joined into a supercontinent called Pangea. The landmasses then slowly drifted to their current positions. What did Pangea look like? Observe. Drag South America close to Africa and look at their coastlines. What do you notice? So I'm dragging here. I'm going to turn a little bit. And notice that the coastlines fit snugly together. Like that. So I explore. Try to fit all the land masses together like a puzzle. As much as possible, avoid overlapping land masses. When you're satisfied, take a screenshot and paste it in below. Label this Map 2, Fit of the Continents. Okay, so I'm going to try to fit them together better. Let's see here. That looks like it goes there. These look like they already fit pretty close together. Oh, look at that. That fits right into the United States. Where's this go? Here? Let's go up in here. And I don't know, does that work? It kind of works. And I'm going to label it with this label. All right. Analyze. Look at your map of Pangea. How well do the continents fit together? They fit nicely. Is it a perfect fit? No. There are gaps. Think about how the landmasses got from where they were to where they are today. Does it seem realistic that the landmasses could have moved like this? Explain. Yes, because there is a lot of time in 225 million years. Compare. If they move as fast as my fingernails grow, then it would take a very long time to move apart. Compare. If possible, present your map of Pangea to your classmates and teacher. Look at other maps and talk about each one. Are the maps very similar or very different? We can't compare easily in distance learning. If Alfred Wagner showed you a map like this but did not have any other evidence, would you have believed his theory that the continents had moved? Maybe. I know that not many scientists didn't believe him. Scientists believe him. Scientists. There. Activity B. Get the gizmo ready. Click Reset. Under Evidence, choose Fossils. Fossils. Oh, nice. Question. What do fossils and rocks tell us about Pangea? Observe. The brown areas in the gizmo show where fossils of Lystrosaurus have been found. Lystrosaurus looked a bit like a dinosaur, but lived in a time before dinosaurs. On which landmasses did Lyrosaurus live? So Lyrosaurus. So this one, this dark brown one. And so it lived here on Antarctica, Africa, and India. And there. Lystrosaurus probably couldn't swim very far. How might the locations of Lystrosaurus fossils be seen as evidence that the continents were once together? If it couldn't swim far, then it had to walk. The continents must have been together. Explore. Use the fossil evidence to help you make a new map of Pangea. When the map is done, paste a screenshot below and label this Map 3, Fossil Evidence. Alright, so I'm going to do the same thing I did before. Oh, this makes it easier. I think I maybe need to turn this one. Oh, look at this. If I turn it, it fits better. Look at that. It looks like it fits just right. Except for this piece. Maybe this piece goes in the middle. Something like that. And then I remember this one fit in here pretty well, like that. That one fit in there. Oh, I forgot this green piece here. Let's just go somewhere like this. There we go. That'll do. Map 3, Fossil Evidence. Next, how well do the landmasses fit together this time? I'm more sure about the fit. Let's look at this compared to this one. Okay. Now, under Evidence, choose Rocks. The purple areas are mountains that formed when landmasses collided 450 million years ago. The orange areas show rocks that formed about 2 billion years ago. Let's check. Rocks. Oh, look at that. They still fit together. Adjust your map using this evidence, then paste a screenshot of this map below. Label this map Map 4, Rock Evidence. Okay, so yeah, I want to adjust it a little bit. Oh, look, these two kind of fit together here. All right. Yeah. Compare. If possible, compare your map to those of your classmates. We can't compare easily in distance learning. If Wagner showed you this evidence, would you have believed his theory? Yes. It fits the reasoning. Extend your thinking. Click Reset and watch India closely. The Himalayan mountains are found on the border of India and Eurasia. How do you think these mountains are formed? They're formed. So, hit Reset. there. The mountains are formed there. The mountains formed when India slammed into Eurasia. Activity C, ancient ice sheets. Get the gizmo ready. Click reset under evidence, choose glaciers. Reset. Glaciers. Introduction. Glaciers are large, slow-moving sheets of ice. During ice ages, glaciers formed at the North and South poles and spread out to cover large areas. Question. What does evidence of glaciers tell us about Pangea? Observe. The white areas are places that show evidence of massive ice sheet that existed around 250 million years ago. Which landmasses show evidence of ancient glaciers? South America, Africa, India, Australia, Madagascar, and Antarctica. Would you expect to find large glaciers on all of these landmasses today? Explain. I wouldn't expect to see a large glacier here near the equator. I wouldn't expect to see a large glacier up near the equator here. Also here, away from the poles, near the equator, there should be no glacier. No, I wouldn't expect to find large glaciers on the land masses away from the poles. Explore. Drag the land masses together to form a map of Pangea. Try to line up the white areas on each continent. You can use the fossil and rock evidence as well if you like. Paste a screenshot of the map below labeled Map 5, Glacial Evidence. Ooh, these are putting together very nicely. Try the other ones. Analyze. Choose glaciers if necessary and look at the white readings. Does this pattern make more sense now? Yes, it makes a circle, like it was at the poles. Extend your thinking. As glaciers moved away from the poles, rocks stuck to the bottom of the ice were dragged over ground. This left scrapes and scratches on rock outcrops that can still be seen today. The scratches show which direction the glaciers moved. Look at the arrows that show the direction of glacial scratches. What is the pattern? The pattern is outward from the center. Outward from the center. Which landmass do you think was located over the South Pole in the time of Pangea? Why? Do you think? Discuss your answer with your teacher and classmates. I think the landmass here, Antarctica, Africa, so these. You might copy and paste these. Was over the South Pole. Okay, when I finish, I want to make sure that I do a little self-check to see if I learned what I was supposed to. I was supposed to use vocabulary such as glacier, fossil, and ice age to explain the evidence for continental drift. I was able to use that vocabulary, and I could see how the pieces fit together in Pangea.